Hi, everybody. My name is Romain Guy. For those of you who don't know me yet, I'm a software engineer at Google on the Android team. I do a bunch of things. I work primarily on the application framework, the UI toolkit, the home screen, and a couple of tools. So if you have troubles with the home screen or some widgets, it's probably my fault. So you can insult me on our public forums. And today, we're going to talk about how to improve the performance of your UI when the stupid animation is over. Here we go. How many of you have had performance issues in their Android UIs? Raise your hands, don't be shy. Okay, quite a bit. So the rest of you, like, you don't write applications or your code is perfect? Just who never wrote an Android application so far? That's good, I like you guys. At least now you have phones, you can do that. Before we start, throughout the session, I will give you some numbers, like to give you a better understanding of how the various tips and tricks I will give you will improve the performance of your application. Some of those numbers come from recent experiments I did. Some of those numbers are pretty ancient. Some of those numbers are like 18 months old, so that's before Android 1.0. So if I tell you that the application was running at 30 frames per second, it's probably a lot better now, but at least the relative differences will be the same. And all the numbers I will show you were taken on T-Mobile G1, actually a prototype of the T-Mobile G1. And again, if you have one of the newer devices, it's probably better. So this is our agenda. We're going to start with one of my favorite topics, the adapters. So how many of you have ever used a ListView in their application? Okay, how many of you like ListView? That's okay. Well, okay. I don't. Yeah, adapters can be a big pain point when you have a slow, in your UI. Like, it's very often the bottleneck of the performance in applications that use lists and adapters. So we'll see how you can use adapters efficiently. So first of all, this is what I have to say about adapters. They're awesome because they let you do many really cool things, and they let you display various items in a list. Like, you can create list views in which every item is a web view. If you do that, I will be very mad at you because it's a really bad idea in terms of memory usage and performance, but you can. You can also do very simple things like the contact application where you have a simple label, like a simple line of text for every item. Adapters are also very painful to use because they introduce another layer of complexity, another layer of abstraction in your application, and the documentation kind of sucks. That doesn't help. But before we start, I would like to know if you guys know how ListView works. Like, how does the ListView use the adapter? Raise your hand if you think you know how it works. Okay, well, some are more courageous than others. I have a cool animation that will show you how it works. So the adapter, like I said, is just, it's basically the man in the middle. So you have your data source, and the data source on Android is very often just an array of data, like an array of string, or a cursor. Like, the cursor is something that we use a lot on Android. And then you have the ListView. It's the widget that represents the data on the screen. And the adapter is just this little piece of code in the middle that takes the data, converts it into widgets that are then displayed in the ListView. It looks very simple like this, but in practice, the relationship between the adapter and the ListView is very complicated. So there is this method called getView on the adapter that you're probably familiar with. So ListView, for every position in your adapter, so let's say you have 1,000 items, for each item that the ListView wants to display on screen, it will call the getView method on your adapter. And the role of this method is to return a view, a widget, that will then be displayed by ListView. And getView, sometimes, very often, in applications that are poorly written, will return a new view. And creating a new view on Android is unfortunately very expensive, especially if that view comes from an XML file, because you have to inflate it, which involves reflection, and tons of code is actually invoked. So we can't really create a new view for every item you have in the list. Like, let's say you're a crazy person and you have 2,000 contacts in your address book. If you want to scroll through your list of contacts, we really can't create 2,000 views. Like, first of all, they wouldn't fit in memory, but the time it takes to create all of those views, it might be like 50 milliseconds per view, will slow down the scrolling by a lot. So the solution to that is recycling views. And here I have this really cool slide that I had to create 3 times because Keynote kept crashing, so I hope you will appreciate it, that shows how ListView recycle views. So here we have a simple skeleton of a ListView that can display 7 items on screen at the same time. And when the user touches the screen and starts scrolling the list with his finger, 1 item ends up outside of the screen. So what we do is that, so ListView now needs another item to display at the bottom of the list. It could simply call the adapter and say, give me a view, and the adapter could return a new view, but like I said, that would be very expensive. Why do we need to create a new view when we have this one at the top that we don't need to use anymore because it's outside of the screen? So internally, ListView has this fabulous thing that we call the recycler. And it takes the views that are outside of the screen and send them to the recycler. Here you can see that there are several segments because in a ListView, all the items can be of the same nature. They can be represented by the same widgets, or they can be represented by different widgets. So one item can be a text view, another item can be a button. And to do things efficiently, the recycler is able to make the distinction between all those different items. So here, our item was the first type that the ListView knows about. So we put the item in the recycler. And then that item is passed to the adapter. So when we call getView, there's a parameter called convertView by default that is actually a pointer to that view in the recycler. And when we do that, when we pass one of those unused views to the adapter, the goal of the adapter is to reuse that view and simply set the text, change the image, instead of creating a brand new one. So here, the adapter turns our old item 1 into the item 8, and now ListView puts it back. All the items are left unchanged, and that allows us to have very, very performance scrolling. So if you try to fling through a list of 10 items, it will be the same amount of work for ListView as if you were scrolling through a list of 1 billion items. So here's what you should not do. So if you wrote code like that, or if you have that kind of code in your application, you should, at the end of this session, you should go back to your computer and fix it. So this is the getView method of the adapter. So we pass the position of the item that ListView wants. We pass this convertView I just talked about, and the parent. So the parent in this case is always the ListView itself. And in that case, you can see the first line of code in that method, I'm calling inflate to inflate an XML file. That doesn't look like a lot of work. After all, there are only 4 lines of code in that method. But again, doing that while the user is scrolling through a list of items will be very expensive. It will generate a ton of garbage, which will put a lot of strain on the garbage collector. The garbage collector will then pause your application, and you will see the scrolling stutter as the system is trying to keep up with what you're doing in the adapter. So instead of doing this, do this. Just check if the convertView is null. So if the convertView is null, that means that it's probably the first layout in ListView. So then you can actually inflate the views. You have to populate the recycler the first few times. So it's OK to do this first inflation. But if the convertView is not null, just reuse it. You are guaranteed, if your adapter is written correctly, that it will be of the right type. It will be one of the views that you created from the adapter. So you can just cast it to whatever that view is supposed to be in your adapter and reuse its content. So here we're just setting a couple of lines of text inside, and a line of text and an icon. So the difference, even better. OK, I'll show you numbers after that. Even better, we came up with we were working on improving the performance of the contact application for 1.0, and we came up with this cool trick that we call the view holder. So how many of you have ever used this trick? OK, so some of you are good and read the blogs and read the sample code, because it's actually in the SDK. There's an example of that. It's called efficient list adapter, so I think it's kind of clear what the sample is about. Anyway, the idea of a view holder is to minimize the amount of work in the getView method of the adapter. Most of the time, your adapter, even if you reuse the convertView, you will notice that you'll end up doing the same work all over again. So if I go back to the previous slide here, even if I reuse the convert view, I'm still calling find view by ID on the convert view to get the text view and the image view that were inside my item. So do we really need to do that every time? We don't. So the idea of the view holder is simply to hold some data that's related to the item, to the view that's passed by the ListView, and do the work only once. So the way you use that is actually pretty simple. So that's our third variation of the getView method. We still inflate the convert view the first time, and the first time we also create an instance of this class, the view holder. So this is how we call this class, but you can give it any name you want. Usually we like to call it the view holder so that we have a clear understanding of what it does. So you create a new instance of the view holder, and you put inside any kind of data or reference that you need and that you know that you're going to use every time getView is invoked. So in that case, we do the find view by ID the first time, and we store the result of that method call into the view holder. And then we store the view holder as a tag on a view. So a tag is any kind of object that you can set on a view. It can be used by your application to store like some random data. And in this case, we just store a view holder. You're pretty much guaranteed that the framework will never use the tag automatically, except in Cupcake. In one particular case, we introduced a bug, so my fault again. But if you set something in the tag, you are guaranteed that whatever you set will stay there and will always be of the type that you just put there. Now, if we're past a convert view that's not null, we need to reuse that convert view. So the first thing we need to do in the else statement is get the tag on that view, which is our view holder. We cast it, and then we can access directly the text view and the image view. At first, it seems like this would not make that much of a difference. We're just avoiding two calls to find view by ID. But when I ran the three examples on G1 prototype, this is what I came up with. So the first example, so the dumb adapter example, the thing you should never do, and if you're doing it, then that's bad and you should fix it. We get less than 10 frames per second when we try to scroll through a list. So that list in particular was showing one icon and one line of text per item in the list. When you start recycling the views, you can see that the performance becomes much better. And in that case, we get about 27 frames per second. And when you use the view holder, so if you avoid doing those two find view by ID on every time the getView method is called, then the performance goes up even further, and we'll reach 37 frames per second. So just by using those very simple tricks that add just a few lines of code in your adapter, you can improve the performance by like 3 or 4 times very easily. And again, those are very simple tricks. So once you've done it once, you'll understand how it works, and you will be able to do it every time really easily. Now let's talk about backgrounds and images. Don't be greedy. When you set a background drawable on a view, you can set a background drawable as you can pass a drawable instance that you created yourself. You can set a resource that comes from your drawable directory, or you can pass a bitmap or color. The background will always fill the view. That is, it will be as large as your view. Where it can become a problem is when you use something like a bitmap. So if you have a background that comes from a bitmap resource, that bitmap will be stretched to be as big as the view or as small as the view. And the problem here is that scaling a bitmap at runtime is very expensive. One of the reasons for this is that we always turn on the bilinear filtering by default, which makes stretching even slower, but it looks better. And also because Skia, our rendering engine, is currently only implemented in software. So we don't have hardware acceleration for that kind of operation. So to avoid this, make sure that you prescale your bitmaps. If you know that the resource you have will be stretched because the view that you're on which you're going to use it as a background drawable will be bigger than the bitmap, or even smaller, do the prescaling first. Like prescale the bitmap and then set it as a background. And here I have a simple example. I just set, so the image was 640 by 480 pixels large, and I set it as the background of my activity. And then I was drawing the application as fast as I could. So with the default version that was scaling the bitmap at runtime, I can get 25 frames per second. By doing the scaling first and then setting the result of the scaling on the activity background, I get 50 frames per second. So you can double your frame rate if you use bitmaps correctly. And pre-scaling bitmaps is actually really easy. If you have a handle on the bitmap object, you can actually extract it from a bitmap drawable if you want to. There's a getBitmap method. You can use the method of the bitmap class called createScaleBitmap, where you pass the original bitmap, you pass the width and the height of the target size. So most often you will pass the width and the height of the view. And the last parameter should probably always be set to true. It's the bilinear filtering I was talking about because it's a bit slower, but it makes it gives you better results. Window backgrounds. By default, all activities are in a window, and all windows have a default background. So the default background currently on the T-Mobile G1 or on the device that you got at Google I/O is a simple color drawable. So we just fill the screen with a single color. And in some cases, we don't really need to have that background. For instance, if you are writing a maps application and you have a map view that fills the entire screen, that map view is opaque. Like you will never see the background of the window that's behind the map view. Unfortunately, the UI toolkit is really stupid in that situation, and every time it has to refresh the map view, it will still redraw the background of the window, even though you don't see it. Again, totally my fault. So you can be mad at me for that. And actually, it's pretty expensive to draw the window background. The fastest background you can draw is a simple color, like it's a solid color. So this is the default background we have. And on the T-Mobile G1, because of the limitation of the memory bus, it takes about 3 to 4 milliseconds to draw that background. Which means that if you're trying to animate something on screen at 60 frames per second, you already have 4 milliseconds out of the 16 milliseconds you have per frame to be able to achieve that frame rate. So a quarter of your allocated time is already going into something that's totally useless for you. So when you have an application in which you have a view that fills the screen, that covers the entire window background, you can get rid of the window background. And the best way to do this is to create a new theme for your activity. So you just have to create a styles.xml file in the values directory of your application. And this is the exact syntax to create a new theme. The theme can be called can have any name you want. Here I chose the name theme.noBackground, and we inherit from the default theme in Android called Android::theme. And the only item that we have here is a style for the default window background, and we use the special syntax @null to indicate that we don't want any background on our view, on our window. Once you have your theme defined in XML in your resources, you can simply apply it to your activity with this simple attribute, Android::theme, and then the syntax is @style, and actually there's a typo in my slide. It's not noBackground theme, it's theme.noBackground. So the name is theme.noBackground, and here the theme should be theme.noBackground. And by doing that, you will effectively get rid of that background on your window, and you will get a better frame rate. So here we have the version of the application with a background. So we have about 43, 44 frames per second. And without the background, we get up to 50-something frames per second. So it will highly depend on the device you're running on, because it's mostly bound by the memory bus. But you're guaranteed that you're going to get a few frames per second back. So if you're writing a game especially, or a maps application, a GPS application, something that will refresh the entire screen very often, remember to use that trick. Okay, and some good news. I just told you that the framework is really stupid because it draws that window background even though it doesn't need to. As of 3 weeks ago, the framework is not doing that anymore. It's finally a little smarter, and that will be part of the donut release. So in the next version of Android, you won't have to worry about that. Unfortunately, users are still running Android 1.1, and they're starting to get 1.5 on their devices. So please apply that tip. And also, if you keep using that trick in Android on Donut, your application will still run pretty fast and will actually be even better than what the framework does because you won't keep the background in memory and you will save a little of memory. Now let's talk about drawing. So every time you want to redraw a view, you have to call a method called invalidate. It's pretty easy to use, but it can also be very expensive. To give you an idea, if you have a fairly reasonable view hierarchy, so let's say that you create an application like the contacts application, when you call invalidate on one of the widgets on the screen, it can take up to 3 or 4 milliseconds for the framework to do whatever it has to do with that command, and then come back to your view and send you the draw command. Another issue with invalidation is that when you invalidate several views at the same time on screen, so let's say I invalidate a view in the bottom left corner, and at the same time I have a view that's invalidating itself in the top right corner, the framework will take the union of those two regions, which will be pretty much the entire screen, and you will end up invalidating a lot more than what you need. So as much as you can, you should invalidate small regions of the screen. To do this, we have 2 methods called invalidate, and you pass a rectangle, or invalidate, and you pass the coordinates of the rectangle to invalidate. Those methods are part of the API on the view class, and they're really effective to improve the performance of your application. If you invalidate just a tiny portion of the screen, the framework will be smart enough to avoid drawing anything that falls outside of this region. And Skia itself, the rendering engine, will just ignore all the drawing commands that are not part of this dirty region. And actually, I have a demo that shows you how it can be used in an application. So here, I have the emulator, and I'm sure you all did this on the home screen. So when you drag an item around, it follows your finger, and the home screen has to invalidate the screen to be able to draw the icon at the new position when you move it. The first implementation I did of that feature was invalidating the whole screen every time you move the icon. And the system was not able to follow the finger. The icon was lagging behind because it was drawing way too much. So now I'm using this invalidate with a rectangle, and I'll show you exactly what is redrawn every time. So now when I drag an icon around, you can see exactly the portion of the screen that gets redrawn. Everything else is just ignored. And what I just did here, so if you go to the DevTools, that's part, is it that part of the SDK? DevTools? Well, anyway, it's either part of the SDK or available somewhere. You can, somewhere to be defined. It's probably in the source code of the Android system. Send me emails if you can't find it. So if you click that box, show screen updates, every time an invalidate happens, you will see it flash in this beautiful pink color. And it's a really awesome and easy way to debug your application and make sure that you're not updating too much on the screen. So here, for instance, I'm showing you something that's really bad and drives me nuts every time I see it. So that's the new search system in Donut that I demoed yesterday. And when I click the search widget, you can see that for some reason, the entire screen is being redrawn. There's absolutely no reason to do that, so we have to fix it. So please do use that feature. It's pretty awesome. But let me disable it, because it's also pretty annoying. There we go. Now, to give you an idea, so those numbers come actually from the home screen. When I was using invalidate to redraw the icon when it was trying to follow my finger, I was getting about 18 frames per second. And now that it's invalidating only the icon, the new position, and the old position, we get almost 50 frames per second. So the improvements when you do this can be pretty awesome, and they highly depend on the number of views you have in your application. So the more complex your UI, the more you will want to use that kind of trick. Speaking of views, okay, so that's one of my pet peeves. From time to time, I go on the market, I download an application, and I look at its layout and look at the number of views it's using. And very often, I'm really mad at whoever wrote the application. We do our best to have a framework that's fairly solid, that has tons of features, but that's also pretty performant. Unfortunately, we're still running on mobile phones, and no matter what we do, we have constraints in memory, in CPU, in memory bandwidth, that kind of things. And the more views you use, the more views you put in your UI, the worse the performance will be. So if you have too many views, the startup time of the application will be a lot longer. It will take a lot more time to measure and lay out the application. And actually, it can become really bad if you embed several linear layouts that can trigger, each layout can trigger several layout phases. So you can end up, just to lay out the screen once, internally the system might end up doing like the layout 20 or 40 times. And also the drawing will be a lot slower. And some of you may have encountered that issue if you have way too many views, if you have way too many layouts in your view hierarchy, you will even get a Stack Overflow exception. Have you guys ever run into this issue, the Stack Overflow? Yeah, one hand over there. Bad you. The stack, the default stack size on Android is currently 8 kilobytes. That's not much. So that means in Cupcake, if you have about 14 or 15 embedded view groups or layouts, you will hit a Stack Overflow exception. The system doesn't have enough memory to run the code. We increase that size in Donut because we're introducing new features that would cause prime in your applications. But the point here is the more views you use, the slower your application. And actually, sometimes it's not that hard to remove views. And also, it helps you when you debug. Like, the less views you have, the easier it will be to debug your UI. So I'm pretty sure that some of you went to the session this morning by Justin where he showed the hierarchy viewer, but I want to show you that tool again. That's something I use very often. So how many of you use that tool in their day-to-day development? That's not enough. Okay, so hierarchy viewer, let me show you how it works. I will show you the version that's from our tree, but hierarchy viewer is a tool that comes from the SDK, so you can just double-click the hierarchy viewer executable, and you will get pretty much the same tool. So that tool works with the emulator. It also works with devices. Unfortunately, it doesn't work for security reasons with consumer devices. So if you have an ADP1, or even maybe with a phone that you just got yesterday, it might work. But if it doesn't work with a phone, you can just use it with the emulator. So here I can see the list of devices that are attached to my computer. I have only the emulator. And on the right side, I have the list of windows. So I can inspect any window I want, any application I want. And if by default I don't select anything, it's going to choose the window that's currently the foreground window. So then you just click the load viewer hierarchy. And this is asking the device to send a dump of the current UI back to the tool. And then in the tool, you can get an overview of what the view tree looks like. So that's the home screen. And actually, that's a pretty good tree because it's very wide, but it's also very flat. What really matters is that you don't have too many levels in the tree. If it's wide, that's okay. Here at the bottom, you can see how many views you have in the UI. So here we have 39 views. So that includes, the grid with all your applications, all the icons that you have on your home screen, your widgets, all that stuff. A good number of views is usually between 0, and you can go up to 80, 100, but that's pushing it. If you go above that, you really, really need to rethink your UI and improve it. And something we introduced in Cupcake to give you a better idea of whether your changes are improving the application is this little table over there. So those numbers are actually come from the device, and they tell you how much time it took in milliseconds to measure all the views in the hierarchy, how long it took them to do the actual layout, and how long it took to draw them. So those numbers are not perfect because if the device is busy because there's a sync happening in the background, or if an application is using the CPU, those numbers will vary. But it will give you a good idea and a good understanding of what's going on. And here, those numbers actually are actually pretty good, but they should be a lot better. Having 6 milliseconds spent doing the layout of the whole screen, that's actually really good. But spending 30 milliseconds drawing the screen is not good enough. That means you can't animate at 60 frames per second. So that's a really good way to see if you're improving your UI. And usually what you want to look for in the hierarchy viewer tool is places where, I don't think I have an example here, but you want to look for a layout, a view group that has only one child. And if that one child has a width of fill parent and a height of fill parent, then you know that one of those two views is useless. So here, that could be an example. That frame layout could be removed, but that's actually used by the framework for many reasons, so we have to keep it here. So try to look for layouts that have only one child and try to get rid of them. Slides. So once you've looked at your layout in hierarchy viewer and you decided that, yeah, it sucks and you have too many views, you need to fix it. And I don't know how I did that. There we go. And here are a few solutions you can use. The easiest solution is actually to use what we call the compound drawables. I hate that name because it's hard to say for me, and it's really long to type. And it has the worst API name ever. There's a method on TextView called setCompoundDrawable with intrinsic bounds. Yeah, you can laugh. But the idea behind it is if in your UI somewhere you have an image next to a piece of text, usually how people do that is use a linear layout. Then they put an image view for the image and a text view for the text. It seems pretty straightforward and pretty logical. But that means that you have three views to just display an icon and a piece of text. So instead, you can use this feature of text view with its terrible name to replace the linear layout, the text view, and the image view by only one text view. So here I have a simple example. On the left, you see the XML that produced this tree here. We have a horizontal linear layout, an image view on the left, and a piece of text on the right. And the equivalent to this is the XML on the right. So it's pretty much the same text view, except we use this attribute called drawable left that will simply set a bitmap on the left side of the text. You can also set bitmaps above the text, below the text, and on the right. And you can set 4 bitmaps at the same time if for some reason you need to do this. So it's very easy to do, very efficient way to improve your UIs. Now the ViewStub. How many of you ever used the ViewStub or even know what it is? Okay, that's not enough. You guys should, read the docs. Well, the docs that we wrote. We're working on it. So the idea of a ViewStub is whenever you have a UI in which there's a part of the UI that you don't show very often. I'm sure you've all used like the invisible mode or the gone mode of the views to hide them from the UI. So if you have a UI in which part of the UI is most of the time gone or invisible, instead you can use a ViewStub. The idea of a ViewStub is to inflate part of the UI on demand. So a ViewStub is an actual view, but it has a size of 0, so it's 0 pixels wide, 0 pixels high. It doesn't participate in the layout. It doesn't draw anything. So it's really cheap to have a ViewStub in your view hierarchy. And when you create a ViewStub, you give it a reference to an XML layout file. And whenever you call, you make that ViewStub visible, it will remove itself from the view hierarchy and insert the inflated XML layout where it used to be. So here, it's the same tree, and in blue you can see the ViewStub. And now we have the same tree, but the blue subtree actually come from the XML file that the ViewStub knew about. So I called setVisible on the ViewStub disappeared, and instead we get this new bit of UI. It's also an awesome way to create generic screens and without paying the cost of having too many views inside. And this is how you use a ViewStub. It's really easy. So ViewStub must have an ID if you want to be able to get a handle of it, and inflate it. You also probably want to specify the ID of the inflated view. So that's the ID that will be assigned to the view that you inflate with the ViewStub. And you also want to pass the reference to the layout you want to inflate. Now, on the ViewStub, you don't need to specify the layout underscore attributes. So you don't need to give a width, you don't need to give a height. But if you do, those will be automatically assigned to the inflated view from the XML. So it's also a really easy way to reuse an XML layout and still customize it with specific layout attributes in a given screen. So then in your code, what you have to do is find the ViewStub and set its visibility to visible, and magic will happen, and everything will appear in your UI. You can also call the method inflate instead of set visibility visible. The cool thing about doing an inflate is that it returns you a reference to the inflated view, so you don't have to do another find view by ID to find the view that you just inflated. And I know that we use that in several applications, and that's where you can use hierarchy viewer to see how other people write their applications. So if you're wondering how we did some of the default Android application, just grab hierarchy viewer and start inspecting our layouts to see what exactly we did and where we used ViewStubs. Another cool XML tag you can use to improve your hierarchy is called the merge tag. It's a really bad name. I couldn't find any better name. So declaring XML layouts in XML is pretty awesome, but the biggest issue is XML itself. The problem with XML is that you need to have a root tag. You need a root. And if you try to create XML layouts that you reuse in other layouts or that you inflate with the ViewStub, you will very often introduce a view, an extra view in your layout just because you must have a root tag in your XML file. So here we have an example. On the left side, you can see a pretty simple UI, and the blue rectangle comes from an XML that I inflated. And you can see it has a parent that's also a frame layout, and that's totally useless. I don't need to have a frame layout inside the frame layout because the parent frame layout has only one child. So one of them is useless. And the reason why I have this sequence of frame layout is because I included an XML layout, I needed a root tag, so I just put a frame layout there. The merge tag can only be used as the root tag of an XML layout file. And it basically tells the system, ignore me. It doesn't matter, ignore me. All my children will be assigned to whatever parents I would normally have. So if I replace, yeah, somebody's using Android. So if you replace, and shame on you for not turning the sound down. So if you replace the frame layout in the XML file that you're including by a merge tag, then the hierarchy becomes the hierarchy you see on the right. And we have one level less in the hierarchy, so it's more performant, it takes less time to inflate, and so on and so on. So that's how you would use the merge tag in XML. It's really simple. It has no attributes. You just have to put the namespace on the tag. And I wrote a blog about merge, so if you couldn't follow what I just said, go to developer.android.com, click the blog tab, and look at the user interface articles, and you will find more explanations about the merge tag. Relative layout. I think there was a session this morning, I think that was Justin who talked about it. Relative layout is often a very nice way to simplify UIs and to replace a bunch of nested layouts by just one relative layout. It's very powerful. I often use it myself to replace a bunch of linear layouts. The only problem is that it's really hard to use. And I think on the Android team, I'm probably the only one who kind of understand how it works. So very often I get people, come to my desk and like, hey, I'm trying to use a relative layout, but it doesn't work. I'm like, yeah, I know. And again, totally my fault. And the problem is, it does work, but you have to understand how it's implemented to use it in some situations. And I promise I will fix that. I know how to fix it. I just need to find the time to fix it. But I will. Send me, letters of encouragement and emails, or threaten me and do something. Or if you bring me cookies too, because I didn't have lunch. So if you bring me cookies, I might fix the relative layout. Anyway, I also wrote an article about relative layout on the Android blog. If you go there, you will get, I think, a better understanding of how it works. I show in that example how to replace a couple of linear layouts with just one relative layout. And again, don't hesitate to use the hierarchy viewer and inspect the default Android applications to see how we did, we implemented the layouts that we have and to see how we solved that kind of issues. Another awesome tip that you should be using, and I keep telling that to application developers, use custom views, but usually developers are scared of using custom views for some reason. So how many of you ever wrote a custom view? Okay, you're really good. I like you. And the other ones, shame on you. Custom views are awesome because you have control over the view, you know how it's used, so you can take shortcuts and you can improve performance by a lot. The problem we have on the framework team is that we have to write very generic pieces of code, and sometimes it's very hard to optimize them, or the cost of optimizing the view actually ends up costing more in some situations. So here I have an example. It's actually something that we shipped in Cupcake. So the guy who's sitting in my office is working on the Gmail application, and he was having all those performance issues, and I kept telling him, use custom views, use custom views, use custom views. And he finally did, and it's awesome. So the item you see here, an email, so you have a checkbox, 2 lines of text, the time or the date, and a star. That used to be a very complex layout. So there were a bunch of linear layouts, maybe a relative layout. There were a couple of image views, 3 text views. It was a lot of things for something that simple. So instead, in Cupcake, he wrote a custom view. So that's now one view. He's doing all the drawing himself. That gives him a lot more power over the drawing. That's how he can do the different ellipses in the same line of text. And the performance of the Gmail application is now much better. When you scroll through a long list of emails, it's a lot smoother in Cupcake, Android 1.5. So if you can write custom views, please do, and take all the shortcuts you want, all the shortcuts you need to make your application fast. And actually, writing custom views is pretty easy, but I'll get back to that. So that's the skeleton of a custom view. All you have to do is extend the view class. You need to have at least one constructor that takes the context as a parameter. And the only 2 methods that you need to override are onDraw, to do your drawing, and onMeasure. OnMeasure is used to tell the framework how big your view wants to be. When you override onMeasure, you have to call, at the end of the method, setMeasureDimension. If you don't, you will get an exception, and it will tell you that you need to do it. SetMeasureDimension is how you tell the framework, okay, I want to be, in this case, 100 pixels wide and 100 pixels high. We'll get into more details about that in the next session. But just know that the dimensions that you indicate might not be used by the framework. Linear layout, for instance, is really good at that. It asks a text view like how big you want to be. The text view says, oh, I want to be 600 pixels wide, and the linear layout is like, I don't care. You won't be 600 pixels wide. So don't freak out if those are not respected. That's perfectly normal. Use custom layouts. How many of you have ever written custom layouts? Ooh. A lot less. Okay, better. Custom layouts are also awesome. Sometimes I'm sure you all had issues trying to come up with the exact layout you wanted. We try to have some generic layouts that are easy to use. Sometimes they're not, like relative layouts. And in some cases, it's actually a lot simpler to write your own layout than try to fight with the default layouts and come up with the UI you wanted. So this is an application I wrote for Android 1.0. And I wanted a simple grid. I wanted a simple grid of photos. So instead of using a table layout or trying to use a bunch of linear layouts to do what I wanted, I just spent 30 minutes writing my own custom layout that I call the grid layout that can only support 6 items because that's all I wanted on screen. And it's very fast. It's very nice. It does exactly what I want, and I didn't spend my time getting frustrated fighting with the default layouts. Writing custom layouts is similar to writing custom views. It's a bit more complicated. Again, we'll go into the details about custom layouts in the next session. But you extend the view group class you override the onMeasure method. And the difference here is that not only do you have to indicate what size you want to be, but you also have to call measure on all your children. So you want to know, as a layout, you want to know how big the children want to be. So you just go through your children and you measure them. Then you also want to override the onLayout method. And this is actually where you position the children and where you give them a size. So if you write a grid layout like I just did, you just do the simple math that consists in putting the items in the right place. Usually what we do, and what you should always do when you write a custom layout, is ignore the children that have visibility of gone. A children in the gone state must not participate in the layout. It must be totally ignored. And it actually could be ignored in the measure phase as well, but I didn't have enough space on the slide. Invisible children still participate in the layout. They still take the room, but they don't draw. That's the difference between invisible and gone. And finally, memory allocation. So I think the title of the slide says it all. Like, just don't use memory. Sometimes it's difficult to reduce your allocations, and we have a couple of nice tools to help you, remove allocations from your application. And the reason why I'm saying this, it's because our current garbage collector is, I would say, dumb, but it works, so it's still good. The problem is, whenever the garbage collector kicks in, it will stop all your threads. It will interrupt your UI while it's garbage collecting. And a garbage collection can take between about 100 milliseconds to 500 milliseconds. That's a lot of time during which your UI cannot do anything. That's a lot of time during which the user cannot do anything. So if you ever wrote a ListView and you're allocating memory in the getView method, you may have noticed that when you scroll through the list, sometimes you see those little stutters, and that's because the garbage collector is kicking in. You can allocate memory in some places. Those are the methods when you write UIs where you don't want to allocate memory, or as little as you can. So when you're doing measurements, layout, whenever you're drawing something, like, do not create a new paint every time you draw a view. Like, just create the paint once and reuse it. Events handling, those can be very expensive, and you really, really want to avoid allocating memory. To give you an idea, the framework can send you up to like 80 or 90 touch events per second. So if you start allocating memory, the garbage collector will kick in really fast. And the adapters. So when you scroll a ListView, you really don't want the garbage collector to do its job. So one of the tools that we have to help you remove allocations from your application is a cool API in the class called debug. You can set the limit of the numbers of allocations that you want to have in a specific piece of code. So let's say you decided that you're writing a game and you want to have 0 allocation in your drawing code. What you can do is put that code in your application, and if there are allocations that exceed the limit that you specified, in that case 0, then an exception will be thrown, and you will fail fast. You will get the nice stack trace that shows you where the allocation happened. Another cool tool you can use, I don't think it shows up in the Eclipse version of DDMS, but in the SDK you can launch the application called DDMS. And in that application, there is a tab called Allocation Tracker. So you click on that tab, you click on the process you want to inspect, for instance, the home screen. Oops, forgot one step. So the home screen, you click Start Tracking. You go back to your device or your emulator, and you start doing stuff. So I'm using the application, everything's fine. Then I go back to DDMS, I click Get Allocation, and I get a list of all the allocations that the application did during that time frame. So I can see that arrays of int have been allocated. We created, for some reason, a text view, because apparently we created dialogue. So you really can see every single allocation. Even better, if you find an allocation that seems suspicious, you can click on it, and it will give you the full stack trace for that allocation. So you can see what caused the allocation. That's a very, very nice tool, And I used it recently, for instance, in Donut. I discovered that, I think it's in Cupcake, if you long press an empty space on the home screen, it allocates 600 rectangles. There's actually a good reason for that, but I optimized it. So it is an awesome tool, and you should definitely use it. Finally, be better at managing your memory. So how many of you are aware of what those things are? There are some good Java developers in the room. So I'll be really quick because we don't have much time left, but soft references are a special type of reference in Java that can be collected by the garbage collector when the only reference... Okay, let's start over again. A soft reference is a wrapper for an object. If all the references to that object are soft references, and if the garbage collector needs more memory, it will first collect the soft references. So soft references are awesome to create a cache. Let's say I want to keep a lot of bitmaps in memory, but I don't want to run out of memory because I keep those bitmaps in memory. I can put all those bitmaps in soft references, and whenever the system needs memory, I know that those bitmaps will go away first. That means that those objects can disappear at any time, and I'll show you how you can handle that. Weak references are very different. So they're still wrappers for objects, and if all the references to an object are weak references, then the object will automatically be garbage collected. I wrote an article on the Android blog about it, so I will refer you to that. It's an awesome way to avoid memory leaks. So here is, for instance, how you would write a simple memory cache using soft references. So you can put objects in the cache. Each object is identified by a key. And so we have a hash map of strings to soft references. So in the put method, when we put something in the hash map, we just wrap the value that we're given with a soft reference. And then, when we want to get a value out of the cache, we retrieve the soft reference from the hash map, and we have to check we have to call the method get on the reference. Get will give you the value that you put in the soft reference. But that value can be null. It can become null at any time because the garbage collector needed memory. So you have to do that extra check. You have to verify whether or not your object is still in memory. If it is, you can just use it. If it's not, you have to put it back in the cache. We have several examples of that in various applications. So if you go to code.google.com/p/apps-4-android, we have a bunch of open source applications that we wrote, and I think at least a couple of them use soft references for memory caches. And those are, standard Java classes, so there are tons of articles on the web about soft references and weak references. So go to google.com and find articles. And we don't have time to talk about this. So here are some pointers. If you want to learn more about everything I talked about today, go to d.android.com. It's the developer website where you have access to the SDK, the blog, the documentation. Source.android.com if you want to know how to get the source code of Android. It's very interesting to look at our source code, see how we do things. And if you want to learn how to use relative layout, go read the source code. And the last two links are pointers to open source project that we wrote that show how to write good UI code. And now we have some time for your questions. So please go to the mic and speak clearly. No question? I must be very good at teaching stuff then. Oh, the previous slide? Yeah.
Can I ask one?
Sure.
Can you go to the slide for soft references?
Yes. This one?
Yes. In this implementation, since we put all the soft references in the hash map, they are going to be collected by the garbage collector, even though the hash map is not a soft reference?
No. What's contained inside the soft reference can be collected. The hash map keeps a hard reference to the soft references, if you can follow me. So those won't be collected, but what's inside the soft reference can be collected.
So we are going to find a hash map full of null references?
No.
After it's collected?
Yeah, so when you call get on the soft reference, the result might be null because the garbage collector may have reclaimed that reference.
Okay, thank you.
Go to google.com, read articles about it.
Okay, thank you.
It's more so that you're aware of that.
At which point should you recycle bitmaps?
Every time.
So if you in convert view on your list adapter, you're changing the bitmap on an image view, should you recycle the previous?
So it depends. You could recycle the bitmap, but that means the next time you will display that view, you will have to fetch that bitmap again from wherever you took it from. So what you should actually do is use a memory cache of soft references that contains all the bitmaps that you have, and put your bitmaps in there. So you don't bother about recycling them in that case, and they will be collected by the garbage collector if it needs more memory. But the best solution for bitmaps is to use a cache of soft references. If you know that you're not going to reuse the bitmaps, yeah, call recycle on it.
Thank you.
Sure.
I've done a number of extensions of ViewGroup for custom layouts, and there's I think an unimplemented property there that says use child drawing order. Is that something you guys plan to actually finish out at some point? Because it's really useful when you're trying to get semi-transparent views.
It's implemented in Cupcake.
Ah, excellent. Thank you.
Before we take the next question, in room 4, Joe and I will show you how to write a custom layout. So we'll give you all the details about how to do that. And we'll also show you how to commit that code to the Android open source project. So we'll take you through the steps, and we'll show you how we review your code.
Yeah, when you're talking about list views and adapters and such, you were saying the convert view is passed in the correct type, but if you have mixed views, how does it know which one to pass in if you've got different types?
Okay, so that's a really good question. I didn't go into the details because of time constraints, but on the adapter, there are other methods that will tell ListView the type of the view given a position, and that will tell ListView how many types total you have in the adapter. So some of our adapters, the simple adapter, simple cursor adapter, take care of that for you. But if you write your own adapter, look at those methods. And actually, you will see very quickly whether you're doing something wrong. Because if you get a convert view that's like not the right type and you get a class cast exception, then yeah, you know there's something bad going on.
Thank you.
Sure.
You had mentioned about the allocation tracker that is not available in Eclipse. Is there another debugging application that we could download that could, monitor maybe the frame restrace and other problems that we can go in and make sure that our application is running optimal, or is the allocation tracker the only thing we can use?
So you want debugging tools for the UI?
Yeah, just to run around the application.
So actually, that's something I'm working on the side. We have ways to get better. We have ways to get the frame rate, and you can see graphs of all the drawing phases. So we have that, but to enable that, you need to download the source code. You need to turn on the flag in the source code, rebuild the platform, and flash that on your phone. So it's not very user-friendly. So I'm trying to put that in Hierarchy Viewer. I don't know how I'm going to do that yet, but yeah, we're definitely thinking about it.
Okay.
Hey, you mentioned about that when you invalidate a view, it unions the other, it makes a union of all the other views that are invalidated. Yeah. And we ran into that, but our problem was that we weren't calling the invalidate. When you change the text on the text view, it seems like that happens, and we get several text views.
Yeah. So when you modify properties of views, most of these properties will trigger a relayout or an invalidate. That's because if you call setText and then you wouldn't see the new text on screen, you'd be like, oh, what's going on? And we don't want you to call invalidate every time. That's more work for you. So that's why sometimes they invalidate themselves.
Okay.
And you just turn on the screen updates and you'll see what's going on. Yeah.
Hi. Can you comment on how what you would recommend to optimize on the input handling, like events flooding?
Okay. So I'm not the best person to answer that question. If you can find Dan right here knows the answer in the front row. Events flooding. When you're in a game and you get like 80 events per second and your frame rate goes down the drain. Okay. So the answer here is if you're writing an application that has the rendering in a separate thread, the event dispatching will use as much CPU as it can. So the trick is to put a sleep call in the event method. It sounds very bad at first, but apparently that's the way to do it right now. But we're aware of this issue, and we started working on a solution for Donut.
Will this forthcoming native development kit provide us with opportunities to write more complicated views, custom views that might involve complex animation, or will that be very difficult?
With the native development kit?
Yes.
So what you will be able to do with the native development kit, and I don't know all the details, but you'll still have to write the custom views in Java, but you will be able to call into native to do all the drawing yourself.
Do animations and things like
that. But the native development kit will only contain like the libc library. It won't contain OpenGL bindings or things like that. At least in the first version, we want to get the APIs right before we make them public in native code. But we know that it's something that people want to do. It's also something that we would like to do, and we're working on it. And if you have feedback, if you can tell us what exactly you need, just send us emails and we'll look at that.
Great, thank you.
Hey, so when using activity groups, they have a tendency to increase the depth of the views a lot.
So I blame whoever wrote the tabs, and we need to fix that. I'm so sorry.
Okay.
Yeah, hi. I've been trying to get views to render off screen, so maybe to use them on a texture or similar. Mm-hmm. But we're having a problem with the fact that I can't get invalidate calls, because if I inherit the view group, I can't. The invalidate call group it calls to its parent is final, and I can. So, is there any way to get the invalidate callbacks?
So you want to render animations off screen, right?
I want to render any Android views off screen, basically.
If all you need is a snapshot, you can actually do exactly what Hierarchy Viewer is doing. Because I haven't shown you that, but in Hierarchy Viewer you can get
we would like to get them animated as well.
Yes. So in the view class, so first of all, to get a snapshot, in the view class, you have several methods called set drawing cache enabled, get drawing cache, and build drawing cache that will give you a bitmap of the view. That's actually what ListView does. When you scroll a ListView, it just turns all the views into bitmaps. If you want to animate that, the nice thing is calling invalidate on a view will invalidate that cache, and the next time you call get drawing cache, it will update that cache. So it doesn't really matter whether it's calling the parent or whether you can override that method, because
the problem is that when a view invalidates itself, it tells its parent that it's been invalidated. But there's no way for me to get that information.
Okay, I see. To know that it's been invalidated. Yeah, actually there is. If you set on view, there's a method called getViewTreeObserver that will give you a ViewTreeObserver. On that ViewTreeObserver, you can add a listener that will fire your callback every time the hierarchy is redrawing something.
Oh, okay.
And that you can also be notified when there's a layout happening. There's a bunch of things you can see. Okay. And you can even cancel the draws. So if you know that you're going to draw off screen, you will be notified, and you can say, oh, by the way, please don't draw because I'm handling it myself.
Okay, great, thanks.
If you have an adapter and when you build views, you apply animation to it, should you be caching single animation, applying that to multiple views, or new instance of animation object for each view? And what are overall tips and tricks for animations?
So animations, you can definitely reuse animation objects. That actually works really well, and that's actually what we do automatically for layout animations. So yeah, you can cache them and reuse them. And animations are actually that kind of thing that you can put in the view holder, and the next time you need to use it, you just call reset on the animation and you set it again or you start it again, and that should work. Are we good on time? Okay, we're done. Sorry, guys.